hope everyone is staying happy and healthy at home. Today we're going to talk about cerebrovascular accidents, CVAs. A cerebrovascular accident is most commonly known as a stroke. There are different types, which we have learned in classes in the past, but I will briefly go over those again in just a second. Every CVA is different. It can affect each patient in a different way. So according to the American Stroke Association, there are 4 main types of CVA. The ischemic stroke occurs when a vessel supplying blood to the brain is obstructed. It's about 87% of all strokes. The hemorrhagic stroke is caused by a weakened vessel that ruptures and bleeds into the surrounding brain. The blood accumulates and compresses the surrounding brain tissue. This is about 13% of all strokes. A transient ischemic attack, TIA, is mostly known as a mini-stroke. This is a temporary blockage of blood flow to the brain. This can be a warning sign that a major stroke is on the horizon for your patient. Lastly, the American Stroke Association recognizes the cryptogenic stroke. In some instances, despite testing, the cause for a stroke can't be determined. To continue, CVAs can cause behavioral, cognitive, and physical deficits that affect your patient's quality of life. Motor speech impairments can be observed concurrent to stroke-induced aphasia and may also include apraxia of speech, hyperkinetic dysarthria, spastic dysarthria, and other disorders.
So before we can really discuss how the nervous system is affected by a stroke, it's important for us to review the parts of the nervous system. So the nervous system is made up of the central nervous system and the peripheral nervous system. As we know, the central nervous system is made up of the brain and the spinal cord. The brain contains cells that communicate to control movement, emotion, memory, speech, etc. And then the spinal cord sends those messages between the brain and the rest of the body. Then the peripheral nervous system is made up of sensory and motor nerves that go from the spinal cord to the rest of the body. So both of these systems work together to control the body. So an example that I'd like to use to explain the difference between a normal functioning nervous system and a disordered functioning nervous system is when we place our hand on a hot object. In a normal functioning nervous system, when we place that hand, those sensory nerves, the red in that picture on the right, those sensory nerves are going to send a message through those nerves up the spinal cord into the brain. And then that brain is going to send a message from the brain down the spinal cord to the motor peripheral nerves to remove that hand. So you can see that both these systems are working together to achieve that function of pulling that hand away. However, in a disordered nervous system, for example, an individual who suffered from a stroke, those messages may be blocked, slowed, or confused at any point throughout those two different systems. So that message could be delayed in the peripheral sensory nerve, or it could be blocked or delayed in the spinal cord or the brain or in the motor nerves. So it's important to remember that after a stroke, the nervous system as a whole can be affected. So, specifically after a CVA, the nervous system is affected greatly. The nerve cells in the brain tissue have become injured and they cannot communicate with one another, thus affecting all of our bodily functions. Additionally, neuronal pathways in the central nervous system can be damaged. In some cerebrovascular accidents, cranial nerves can be affected directly, and will impair the ability of our cranial nerves to transmit motor impulses to the muscles. Now, this most commonly happens in a stroke that occurs in the brainstem because the cranial nerve nuclei are found within the lower motor neurons, which are housed within the brainstem. So, following a stroke, due to all the damages that have occurred, the brain begins to reorganize. So, spared neuronal axons spread to innervate the impaired areas and establish new neural circuits to recover from those lost functions. So as you can see in the picture in the middle, these are two neurons, and right where they're meeting there, that synapse, our brain is going to try to repair those synapses, those pathways. So reorganization can partially restore motor functions, but the effects are limited and can sometimes be harmful to recovery in larger stroke lesions. And finally, to obtain the greatest gains of your sensory and motor functions after a stroke, those surviving neural circuits need to be regularly reorganized to make new connections.
A CVA can cause several different types of motor speech disorders, most commonly dysarthria or apraxia. Speech can be impaired if areas of the brain responsible for programming and muscle control are damaged. The type of motor speech disorder depends on the location of damage. The severity of impairment depends on the number of neurons lost during the stroke. There are several different types of dysarthria that can be caused by a CVA. Flaccid dysarthria is caused by a brainstem stroke. This can directly impair the cranial nerves that assist in speech production. Spastic dysarthria is caused by bilateral damage to the pyramidal and extrapyramidal tracts. This only occurs when there are two or more strokes that occur in a certain combination, or the stroke is in the brainstem. Unilateral upper motor neuron dysarthria is caused by a stroke that happens anywhere in the brain that has upper motor neurons. Strokes that are located in the frontal lobe and cause damage to the internal capsule are the most common cause of this dysarthria. Ataxic dysarthria is caused by a stroke that damages the cerebellum. Hypokinetic dysarthria is caused by a stroke affecting the basal ganglia. Hyperkinetic dysarthria is also caused by a stroke affecting the basal ganglia or nearby areas such as the thalamus. Mixed dysarthria is caused by damage in two or more parts of the motor system. This means there are characteristics from two or more of the previously mentioned pure dysarthrias. The location of damage determines which characteristics are present. Finally, stroke can also cause apraxia of speech. This most commonly occurs when there is damage to the parasylvian areas in the left hemisphere of the brain. Strokes typically occur in the frontal and parietal lobe, but there are cases of co-occurring damage in the temporal lobe as well.
All right, so next we're going to talk about some motor speech disorders that could result from a CVA. First, we're going to talk about the 7 different types of dysarthria, starting with flaccid dysarthria, which is caused by damage to the lower motor neurons. Someone with flaccid dysarthria could experience speech that is consisting of slow labored articulation, as well as hypernasal resonance and hoarse or breathy phonation. Next, we have spastic dysarthria, which accounts for 7.6% of motor speech disorder cases. Someone with spastic dysarthria could present speech that is slow, effortful, have harsh vocal quality, and may display imprecise articulation, monotonous pitch or loudness, as well as poor prosody. Next, we're going to talk about unilateral upper motor neuron dysarthria, which I thought was really interesting because there are fewer published definitions of unilateral upper motor neuron dysarthria than any other type of dysarthria due to the recent recognition, and there were actually few studies of this disorder before the 1980s. Someone who presents with unilateral upper motor neuron dysarthria may present mild articulation deficits, slow diadochokinesis, and other voice disorders. Ataxic dysarthria is a disorder of sensory motor control for speech production. This type of dysarthria has been linked to drunken speech and primarily presents errors in articulation and prosody. Next, we have hypokinetic dysarthria, which may result from a stroke but could also result from Parkinson's disease. Speech could be noted to have reduced vocal loudness, harsh or breathy vocal quality, as well as abnormal speaking rates. Characteristics are most evident in voice articulation and prosody. Hyperkinetic dysarthria is actually quite difficult to define because it can result from so many different disorders. Speech can be characterized by variable articulatory imprecisions, as well as vocal harshness and prosodic abnormalities. And the last type of dysarthria we have is mixed dysarthria, which results from a combination of multiple dysarthrias. So speech, of course, is a combination of the characteristics found in the single dysarthrias, and the location and extent of the neurological damage will determine those speech characteristics. And last, we have apraxia-speech, which is a deficit in the ability to select and sequence motor commands needed to correctly position articulators during production of phonemes. Speech is often described as slow, labored, and halting with inconsistent articulation errors. There are also possible instances of articulatory groping, which is especially noticeable at the beginning of an utterance. Apraxia speech can affect articulation, prosody, respiration, resonance, as well as phonation. And last, we have our references. Thanks for watching.